This episode is brought to you by Shopify. Upgrade your business with Shopify, home of the #1 checkout on the planet. Shop Pay boosts conversions up to 50%, meaning fewer carts going abandoned and more sales going cha-ching. So if you're into growing your business, get a commerce platform that's ready to sell wherever your customers are. Visit shopify.com to upgrade your selling today.
Hello and welcome to Carbon Removal Newsroom. I'm Ross Kenyon, lead strategist with the Nori Carbon Removal Marketplace. Today I have with us Jeff Holmes, who is business development and self-described perpetual DAC enthusiast, DAC being direct air capture, here to talk about exciting things happening up in British Columbia here with carbon engineering. So Jeff, what is carbon engineering and what is the big news that happened this week?
Well, yeah. And I mean, first of all, Ross, thanks for having me. It's a pleasure to talk with you. So Carbon Engineering is a company that our founder, David Keith, started back in 2009 and grabbed a bunch of us who were in his academic research group and forced us to work even harder on air capture ever since. So we've grown to a team of over 50 now. We've obviously been working on DAC since 2009, so going almost 10 years. And we just completed a really exciting financing round where we secured $68 million to take our technology into mainstream markets.
Yeah, that is a very big deal. It's a lot of money in DAC. I'm curious, who is investing and why? Is there a market for DAC? Are people paying to sequester carbon dioxide that's captured? Are they using it? What is happening with this money and what are you growing into?
Yeah, well, maybe let's start with the markets first, and then I think that's going to make our investors make a lot more sense. So since the get-go, we've had a very strong interest in using industrial scale direct air capture technology to capture and purify CO2 straight from atmospheric air. And, the obvious thing you can do with that is do safe geological injection to put it underground permanently. And there's different ways to describe that. Some people call it carbon removal. Other people call it negative emissions. But the idea is to take a quantity of CO2 back out of the atmosphere and permanently store it away as a means of compensating for or offsetting emissions that are created by producing and using fossil fuels. So there's lots of places we can reduce the amount of fossil fuels we're consuming and cut emissions at source, or there's ways we can do energy efficiency or use fossil fuels more cleanly. But then there's other parts of the economy where controlling or eliminating those emissions at source can prove quite difficult or quite costly. And so DAC comes in as an alternative and a complement to the other ways we have of dealing with climate change to create negative emissions and thus bring our net emissions down as fast as possible and ideally to zero. The other thing you can do with direct air capture is you can capture and purify atmospheric CO2, which can then be combined with renewable hydrogen. So that's hydrogen that is produced by splitting water with clean electricity. And you can take the atmospheric carbon dioxide and the hydrogen, and you can thermocatalytically recombine them so that they form hydrocarbon fuels or fuel precursors. So we could directly manufacture products like gasoline, diesel, or jet fuel, or we could manufacture synthetic crude that can then be refined into those fuels. And we can do so with either very minimal or even no fossil energy in the process. So then we've got a dense energy carrier. We got a fuel that's compatible with modern infrastructure and engines, but it's very, very low carbon intensity on a life cycle basis. And it's also clean burning. So those are the two use cases of air capture that we've been most excited about over the years and that we're seriously taking to commercial markets now.
And then the $68 million round that just closed, who are they and why are they interested in direct air capture?
Yeah, so to connect the dots here, you might ask, who's going to pay for this or how is it going to work economically? And here's where I'll start. I'll put my policy wonk hat on, but try to make it accessible. We've got a growing set of markets out there. So one example is California, another is here at home in British Columbia, and there are a few others. And they have regulations on the books that compel their fuel industry to produce cleaner and cleaner fuels year after year. And so what's happening is refiners and fuel producers and fuel importers are starting to look for ways to reduce the carbon emissions associated with producing and using fossil fuels. They're looking for ways to switch to electricity and hydrogen and fuel cell vehicles. And they're looking for clean fuels. So that could be a biodiesel, or it could be fuel made from municipal solid waste, or it could be the kind of fuels that our facilities will eventually produce also. And when you bring those clean fuels into the market, you generate credits that are worth money and that are saleable on open liquid markets. And sort of an underappreciated fact is that in California, those credits are now worth over $180 per ton. So the California LCFS is quite often referred to as the best piece of climate policy that nobody's ever heard of. So we have markets where we can make clean fuels, we can take them to market and get paid for their value as a fuel, generate credits, and monetize the environmental value associated with those fuels as well. And then just recently, so last fall, the regulator in California also adopted a thing called a CCS protocol. And that's their regulatory instrument for allowing credits to be generated by carbon capture projects. And direct air capture is included in that protocol. So we're actually able to generate LCFS credits by storing CO2 underground, as long as we do so in a way that meets all of their very thorough permanence criteria, to ensure that they're only issuing credits on the net flow of CO2 underground, and that the flow of CO2 underground is indeed permanent. So we've got market mechanisms out there that are ready to pay for direct air capture and for synthetic fuels. And the prices and the economics are looking attractive when we take our engineering and apply it at large scale. And hence we were able to generate significant interest in this financing round based on those early markets, and based on the thesis that the world's going to get serious about climate change, and that there are going to be more of these markets in the future rather than less.
And we did a previous episode of Carbon Removal Newsroom on the prediction that oil and gas companies may find themselves in a position to become direct air capture companies or have divisions devoted to this, because they have the technology and infrastructure to start putting carbon dioxide under the ground. They have this experience from enhanced oil recovery. I don't want to put words in your mouth or force you to make a prediction, but do you think that oil and gas will increasingly be interested and invest in direct air capture?
Yeah, I mean, it's a perfect lead-in, Ross. So I never answered your original question about who was in the financing round, and
I didn't know if you were being coy or not, Jeff. And I was going to give you a free pass, but I have the list here, and I'm prepared to
reveal the names. Our lead investors in that round were Occidental Petroleum and Chevron Technology Ventures and BHP, which is a big mining and minerals company, and they're interested collectively in direct air capture and air to fuels and ways to make their businesses more competitive and more attractive in a changing world. So I can't really close the loop and speculate or specify on exactly why they invested, but your line of questioning is very good. There are oil companies out there like Occidental Petroleum is a perfect example, who move carbon dioxide around and safely inject it underground, and have been doing so for decades. And if we want to start capturing atmospheric CO2 and putting it underground for environmental and economic purposes, then those companies start to look like ideal partners. So we're ecstatic to have the strategic investors that we do in this round, and to have the support of several venture capital funds and a couple of financial asset management entities. So overall, it's great to have the financing done and the money in the bank and the ability to finance our next steps. But it's equally great to have a growing cohort of partners, both indicating credibility and viability of our technology, and partners to help us execute this next step.
Definitely. And then this number I see in the article that we shared, there's a bunch of articles that came out about this round closing, but we'll link to one in the show notes in case you're curious. $100 a ton of carbon dioxide pulled out of the atmosphere. That's the number that you are putting the flag in the ground saying that this is how much we're expecting direct air capture to cost, at least for carbon engineering. How did you get to that number? How far off are we from that? Is that where it stops, or does it continue to go down and become cheaper and cheaper as it scales?
Yeah, I mean, the glib answer, Ross, is we got to that number with 9 years of engineering and building hardware and testing it. So untold, effort by our team here. The way we look at that, we have been designing and engineering our direct air capture process for a long time now. And every year we add a little bit more depth, a little bit more realism, a little bit more real world data from the pilot plant that we've built and operate. And that's the result of a full engineering cost analysis that includes the capital cost of the plant and repaying that at reasonable rates. And it includes the energy and material requirements of operating such a plant. It's, we've put some pretty thorough work out in the public domain. We published a peer-reviewed paper in 2018 that actually gives a lot of detail behind that number. And I think the point to make is it's not a future number. It is a number that is calculated from our current technology set applied at a large commercial scale installation. So we're going to have to do first projects that are smaller than our reference scale, and so those are going to cost more on a per ton basis. But once we get through those first plants and get to full scale where the economics are best, then all of our best engineering and design and economics say we'll be at that $100 per ton number. In terms of going down further, again, it's a bit of a fool's errand to speculate exactly how it's going to happen or how fast it will happen, but we know that it can happen. We're certainly not going to freeze the design today and say, okay, that's done. That's all the work we're ever going to do on air capture. It can't get any better than this. We've got a whole group within the company working on the next innovations of how we do this particular step better or cheaper or faster, and other design methodologies or even other processes that, if and when they reach a point where they're mature enough to make it into our baseline offering or replace certain units in our system, then we'll do so. So we're going to keep innovating, keep bringing the cost down, and can't really speculate on how low it goes, but we'll keep working on it.
I think that was appropriately circumspect. So that's a fine answer by me, Jeff. We're running up against the edge of how long I aim to keep these things. We want to have them be pretty tight for our audience, and maybe there's just too much to talk about in one single episode, and we should revisit with reversing climate change. But I was wondering if you give me a quick answer. What is unique about carbon engineering relative to some of the other direct air capture companies out there?
Well, I think the first thing I want to say, Ross, is that there are very few direct air capture companies out there. So it was a bit of an overlooked technology for a number of years. And so there really there's quite a small community of companies that have raised and are spending serious money on direct air capture. We've got a great cohort of companies working on this. The one thing that differentiates us a little bit is a few of the other serious companies have gone after air capture processes that are based on solid adsorption and desorption of CO2 using some pretty specialized materials. And there's a bunch of things about that philosophy that are very clever, but we're a little bit unique in that we use a liquid capture media to absorb CO2 from the air. And then we do what's called chemical regeneration on the liquid stream once it's captured CO2. And what that allows us to do is actually go out and use a lot of equipment and unit operations that are already in existence in other industries, and some of which even have like 100 years of industrial heritage and experience behind them. And therefore, we've got equipment vendors and suppliers and known supply chains that we can rely on to build these large facilities. And that's going to greatly reduce our risk as we go to building larger DAC facilities. And it lets us achieve what we think are lower unit economics than the competitors in the near term.
Okay. Sounds good. There's so much to talk about here. This is really too much to cover in one. But okay, let's wrap this up, Jeff, and let's just have you back on some other time on another episode of Carbon Removal Newsroom, or maybe Reversing Climate Change itself. What should we expect from carbon engineering moving forward? Anything we should keep our eyes peeled for?
I think keep your eyes peeled for progress on these first commercial facilities and the work that we're going to do in British Columbia here at our headquarters to get the technology ready and wrapped up in a full commercial technology transfer package. Yeah, I mean, watch for progress on the first few entities. Watch for growing interest in direct air capture and carbon removal as a whole. Watch for, I think there's going to be a really interesting and exciting discussion in the U.S. political sphere about carbon capture and utilization and storage. It's proving to be one of those topics that both parties actually agree on for sometimes differing reasons, but can agree is a good thing. So we might see some encouraging things out of the political space too.
Yeah, we keep seeing stuff like that, but very little of it makes the non-specialized news. I mean, there's so much happening right now in climate change generally. So I'm sure it's hard for journalists to know which way to look, especially as carbon capture, carbon removal still seems to be covered more by tech journals, places like Wired, who are excited about it because it sounds sort of cool and science fiction, as I often say. But I think it's definitely going to get more mainstream attention, and hopefully you're helping to push them that direction, because this is when oil and gas invests in something, that's something that I think people should pay attention to.
Yeah, and that's really intentional, Ross. I mean, we want the mainstream public to know that these technologies are out there, and we want them to take more and more interest in climate change and in the solutions that exist for it. And we think that, the more we can show people inspiring solutions that, keep the lights on and engines running while reducing our emissions, the more people are going to be really inspired to solve the problem. So that's part of our efforts too.
Definitely. And that's the point of this podcast, is we want to elevate the conversation about carbon removal. It needs to be a part of the national and international conversations about climate change. We can't get there without it, and this tech is coming. So thank you so much for being here with us, Jeff. If you like the show, please write us a nice review on iTunes or Apple Podcasts. That helps more than you might think. And thank you so much for being here, Jeff.
My pleasure, Ross. I'm happy to talk again.